All right. Welcome, everybody, to episode 5 of Civil Discourse. My guest is JibbyJedi, and there's a slight potential that we have another guest coming in. And I see Factard is in the chat. Hello, Factard. And Jibby, please say hello, and we'll get started.
Hello again. Hopefully we will get Jimbo, but I'm still waiting to hear back from him. If not, we'll just bang this out without him, and we'll talk to Jimbo another day.
So, anything new on your mind, Jibby? Anything come across your plate since the last we spoke?
Well, flat earthers in mortal peril is the new kind of thing going on. We have two flat earthers who are who could use some love and support from the entire community, not just
Yeah, you mentioned Chris. You mentioned Chris Rock, and yeah,
yes,
he's a solid guy.
Yep, he's dealing with some cancer, and we're all going to have a fundraiser for him probably next weekend. People have been donating to him though since
is there a like a GoFundMe link or
he's got a
anything?
GoFundMe, and he has a PayPal link. It's in his video from a couple days ago. Vinny TV has been broadcasting it 24/7. He might be down right now, but we're going to crank up a 24-hour OBS style fundraiser hangout for Chris.
Okay,
next weekend.
So like a telethon.
We have Mr. Josh Walker, also known as Uber Flat Earth.
Okay.
He's in the ICU right now.
Oh.
With pneumonia.
And, that's no joke.
He went into some kind of a diabetic shock. The nurses were saying they've never seen sugar this high. It was somewhere around 1,000 or something. His sugar numbers. It was so he's intubated right now, but he's stable, and he should recover. But he was talking a little crazy. Like one of the things that stood out was that he said, "Oh, the water that they were giving him at the hospital." He's like, the water's from Walmart." And the nurse said, "Yeah, it is from Walmart. I don't know how he knew that." Like,
wow.
Like he's walking around the planes of existence. He's in
right.
and out. So
right.
I'm curious of what he's going to say when he gets back with it. But he had a very, very, very close call. ICU.
Yeah. Well, a lot of people don't realize that pneumonia. I mean, it sounds like such a common word, and it's like, oh yeah, he came down with pneumonia, whatever. And it's like, it is no joke. It is a serious. Like if you don't catch it early,
well,
I think
Yeah, and this is my problem with these vape pens and these vape cigarettes, because to me, you're trying to give yourself pneumonia. You're putting this dense water vapor right directly into your lungs. And I know the long-term effects of inhaling cigarette smoke or other types of smoke, but I don't know the long-term effects of these new vapes. And for him to be in beautiful sunny California in the start of summer suffering from pneumonia, that's strange. It's very strange. He's a young guy too, 36 or so, 37.
Well, we will pray for them and their families, and I'll be happy to participate in your telethon. And so if you have any links, for any of those, like the GoFundMe, I'll be happy to put them, in the description box of this channel, and we get these guys their support.
I can screen share what I have right now, and people can look at it.
Because I remember Chris Rock, when I guess it was 2.5, almost 3 years ago, he was putting out the series of like little 3-minute proof debates, proof videos for flat Earth and against the globe, and I engaged him with the comments, but he eventually asked me to stop politely, because he was thinking that I was open-minded, because I'm polite in my comments, and so sometimes people read that as like, oh, I'm open-minded, and as opposed to I know it's a globe. And so eventually he realized that he wasn't going to convince me, and so he kindly asked me to stop, and so I did, because I don't want to be a troll on anyone's account. But then I ran into him a couple times.
Are you admitting you're closed-minded?
I'm admitting I go with the facts. All right, so I'm going to put this. All right, so it's PayPal.me.
Chris Rock. That should be the main one right
Rock.
there.
Okay.
He'll get the maximum amount of your donation, I think, with that one.
All right. I think it didn't turn into a link. All right, so I'm going to do this again. Pay.me. I just wanted to give it so that people can oh, it's not, oh, it is a link. Okay, so that last one is a link. And so this next one is GoFundMe.com/FUJH7-help. This eat.
And that day of the fundraiser, all flags are down. Ball earthers, hollow earthers, concave earthers, V arthers, all are welcome. No debating, no hate, no nothing that day. This is just pure. We're trying to help a fellow human being, and who's a very good guy in his heart. His heart's always in the right place, and very kind-hearted. And that's all it's
right.
about.
And the thing is, he's as solid as they come. He's a sincere guy. He goes for, from the heart. And I've never heard him say a crossword to anyone. And so, he does deserve our support, and so I'll be happy to participate.
Yeah,
so
hopefully it works out well.
Yeah.
For him. All right, let me see. I need to find the watch page for us now. Here we go. Okay. There we
are. Yeah, so Cinnamon Control was asking about the hearts. The thing is, the way I personally use the hearts is I would like people to know that I am formally acknowledging their comment, and it's like I am extremely liberal with my heart. So maybe the hearts they can't be used as currency because I give them out quite freely, but I do want to acknowledge people's contributions, and like even if somebody is disagreeing with me, I will give a heart to their comment if it's a worthy debate opponent criticism or comment. But yeah, the comments were kind of blowing up for Slick James Johnson. He was on, I guess, two nights ago, and so the comments have been very active. So I do appreciate that. But last night's show was very strange because my guest was a Glober, and like I said, I normally try to have flat Earth folks on here, but he essentially wanted Globe folks to stop debating, because it's not gonna change the flat Earth debate. It's not gonna stop the flat Earth debate. The only thing that's gonna stop the flat Earth debate is if Globers stop participating and stop giving it oxygen. And
yes,
I've read that.
Not give us attention. Absolutely not. We don't deserve it. We're flat-tarded. Well, Jaron just had something where I guess an astronaut pointed a camera out a window to show us a satellite going by, and I haven't seen it yet. But from what I heard from David Weiss on the Flat Earth podcast, he said it looked pretty crappy. So Jaron, who used to live in space, pulled his curtain back again, and I guess saw a better looking satellite fly by. Like, I guess he did a better job than they did on the ISS, like, to make it believable. But we do want these proofs. We want to be acknowledged, and
right.
That's it. We want the non-paper facts proof. Like, I always say explanations are not proof, because explanations are how a cheating husband gets away with it, because his explanations make sense. But
it's like, who are you going to believe, me or your lying eyes, right?
Well, you know what? The eyes can lie to you. The eyes can't play tricks on you. We do have pyramid vision. We do have kind of GoPro-y. We have to understand our own vision. We have to understand perspective. We have to understand these things that we just didn't really focus on in school that much.
Yeah, I agree. Can I get back to that video of the satellite going past the ISS?
Sure.
Um, I don't know the facts. I did see the video, and I don't know the facts because oftentimes the caption gets deleted, and that's something that really frustrates me about a lot of flat Earth videos. Is they'll show an image or they'll show a video, and they'll delete the caption, and then they'll kind of misportray it, and then somebody mirrors it, and then the mirror is the misportrayal, and so what I saw was a small cube, and it was very, very close to the ISS, traveling at the same speed as the ISS. And that tells me that it was a release from the ISS. It might have been one of these microsatellites. Like I have seen them like manually release a microsatellite. It's a guy on a spacewalk and he literally just chucks it. He chucks it into space. And so the thing is there, and I'm like 99.999% sure that wasn't just, oh, the ISS just happened to pass by a satellite. Because there is no way in HE double hockey sticks that they would let an actual satellite get within, 10 kilometers of the ISS. Because that's just a super dangerous situation, because like it could be like game over,
But how
if
can
a
they
satellite.
stop that?
I'm sorry?
How can they stop the satellite?
Oh, well, they could change the altitude of the ISS, and they know exactly where the satellites are, and I think that the ISS orbit is not in an orbit that is used by satellites. Most satellites that orbit the Earth orbit much lower. My understanding is, and then of course the geostationary are much further away. But kind of like air traffic control. I mean, you don't let two airplanes get within a half a mile of each other, just for safety's concerns. So
Is there any video in existence of this ISS igniting their boosters, showing their boosters
they don't.
active?
Well, the thing is, the boosters are on one of the. I don't know if it's on one of the Soviet segments. I forget the name of that. It's something in Russian, and it's at the rear of it. So it's like if you look at the ISS is going in a direction that is tangent to the Earth's surface, the rocket is pointed. It's as if you imagine the ISS is a plane, the boosters are at the rear of the plane, aiming tangent to the Earth's surface. Does that make sense? In other words, it's not the booster isn't aiming towards the Earth; it's aiming towards the tail. And so there are no cameras. My understanding is like that's the back of the ISS. Like there's nothing further back than that.
How does it lift the whole length of the football field size ISS just having boosters in the back end?
It doesn't lift it. It increases its velocity. Okay, so when you increase an orbital body's velocity, that slightly increases the orbital parameters, or it's like you're giving it more centrifugal force, and obviously gravity is not going to change. So if you increase the centrifugal force, it's going to lift it away from the Earth.
All right, I see. As they say, it's falling around the Earth. So accelerating it more, this will change the 17,500 mile per hour speed then, and now it will have a higher speed.
Yes, but and by 1 or 2 kilometers per hour. I mean, I don't know what the actual speeds are. That's actually something I have not researched, but I have seen videos inside the ISS when, like, periodically they do these boosts. I mean, they're many times a month they'll do these boosts, and it's part of station keeping. And so when they do one of these boosts, then they're not in zero gravity anymore. They're now in a slightly smaller form of microgravity. So was a guy who was inside the ISS, and he was like holding one of those big zoom cameras, and he was like, "Watch this," and he held it up and he just let it go, and the camera like literally moved towards the rear of the station because they were actually accelerating.
So they're in atmosphere then?
No. The guy who was inside one of the modules.
But if they're in a pretty much zero G environment, hitting the booster should not make anything feel that kind of force. No, unless you're in atmosphere.
No, the atmosphere has nothing to do with it. So they're essentially in the vacuum of space. Of course, it's not a perfect vacuum.
Well, there's still a whole other layer. There's the exosphere above it. They're only at the center of the thermosphere. There's a whole other exosphere.
Right, but that's just a name. We're talking about like one gas molecule per billion or something like
It's got
that.
to
I
be
mean,
enough to measure the temperature. Otherwise,
yeah, but you're now changing the subject. So the guy was inside one of the modules, breathing the air of the ISS. So he's in his, khakis and polo shirt, and he picked up a camera. I mean, like, obviously he's got his foot in like one of these footrests things that he's not floating around. So he just like, hey, we're currently undergoing a boost, and I want to show you something. And so he holds up his camera and he just lets it go, and it drifts very slowly out of his grasp. Because this wasn't a massive acceleration. It's not like stomping your foot at the on the accelerator green light, but it's the effect is the same. If you do accelerate, you get pushed back in your seat towards the rear of the vehicle. All right, and that's exactly what was happening there. So they were experiencing acceleration. So the ISS itself was accelerating very, very slowly, but it was accelerating to a higher velocity, a very slightly higher velocity, which in turn would raise its altitude above the Earth.
And then there's a force of friction slowing them down.
Oh yes, yeah, they are slowing down because, like I said, it may be one gas molecule per billion, but
and that one
does
gas molecule is 2,000 plus degrees Fahrenheit.
Right,
No?
which you would never notice because a gas molecule that when it's that close to being a perfect vacuum, it really doesn't matter the temperature of an individual molecule. So I don't know if you knew this, Jebby. Yes. Do you know that temperature is simply a measure of vibrational speed? Did you know that?
Yes. Cymatics are a huge part of reality.
So no, I mean an actual molecule that is vibrating. Okay.
Isn't that how they heat up things in a microwave? They basically accelerate.
Yes, but let's just talk about a single molecule. So if you have a single molecule and it is vibrating and it is in what we'll call a near vacuum, okay, that single molecule could be at 1 billion degrees. In other words, it's just a measure of how fast it's vibrating. If that single molecule bounced off of something like the wall of the vacuum chamber, the wall of the vacuum chamber isn't going to say, "Oh, you burned me. That's hot." The what we express as heat, or what we perceive as heat, is when these molecules are much denser together. So if you have an extraordinarily high dense of molecules, such as the air we breathe, or a solid surface, and those things are vibrating at the same speed that this single molecule is vibrating, well, that's when you get what we perceive as heat. And then you can say, oh, if you touch that, then you get burned. Does that make sense? So like in the thermosphere, yeah, you can have 2,000 degrees.
But if your thermometer is measuring the temperature, I would akin that to like a spark from the fire landing on you. One molecule, one spark. That spark will burn you. That one molecule would burn a hole in the ISS.
Well, I think you're overestimating the power of a molecule. So the spark that comes out of the fire is probably made up of 1 million molecules. Okay, so yes, it does have enough mass to actually burn you. But if a single molecule popped out of the fire and bounced off your skin, you'd never notice. In fact, the concept of temperature breaks down when we talk about the molecular level, because temperature is just vibration of molecules.
So what kind of thermometer are they using to measure the temperature of the thermosphere? It must be enough to burn. No?
Well, the thing is, they don't stick a mercury thermometer out the window of a spacecraft and like,
yeah, I'm curious.
What's the temperature out here? So a lot of times people they misunderstand what they talk about when they talk about the thermosphere or the temperature of the thermosphere. The temperature that we experience as hot versus cold is based on a dense quantity, or a density of gas. But if those individual molecules are still at 2,000 degrees, but now we're in a vacuum chamber or a near vacuum chamber, we don't perceive heat. We would perceive that as being extremely, extremely cold, even though you're being occasionally bounced into by a 2,000 degree molecule. And like I said, the concept of 2,000 degrees breaks down when we're talking about individual molecules.
It's got to have an effect. It has to. You can't say that something measured 2,000 degrees has no effect on anything.
Well, I'm not saying it's
being
not
measured.
having that effect. It's not going to have the same effect as if you got hit by an ember coming out of
Well,
a
no,
campfire.
no. I mean, that was just an example, but it's got to have an effect, and the structure, and then the boosters. What kinetic transfer of energy effect is this having on the O-rings and all the joints and everything? Especially it's in the back, so now you're moving a whole football field of connected empty soda cans.
So
You know,
so you notice
apparently they're feeling the force of friction. Now apply that 2,000 degrees not to a stationary object, but an object moving 17,500 miles an hour. This friction, this heat, and a moving object up there is much worse than a stationary one.
So Jibby, I just want to point out your use of cartoon language.
I got this from a PhD from MIT as a PhD in
and he
physics.
called it a set of empty soda cans.
No, that's my
okay. So and I'm just going to call you on it, Jibby. You know that. The thing is, when we think about traveling 17,500 miles an hour, we think about doing that through air. And also when something re-enters into the it burns up, it re-enters from the from orbit, like that Chinese space station. We think of, it's going so fast, it's actually burning up in the atmosphere, that it's going so fast. Well, it's burning up when it reaches a dense quantity of gas. Things that are not in a dense quantity of gas, hitting 1 molecule per billion, and again, I just made that number up, I don't know what the actual density is of gas where the ISS is orbiting, is not going to have this burning effect, even if those molecules are quote unquote at 2,000 degrees. It's very hard, and let me just finish this. It's very hard to get your mind around the concept of the temperature of an individual molecule in a near vacuum, right? And then on top of that, 17,500 miles an hour. But the drag is very, very slow, or the drag is very subtle, and there's no burning that goes on.
I brought this up to a gentleman who walked by us last summer. I'll screen share it right here. This video you can no longer see because somebody was playing the Doors or something in the background, and the YouTube shut the thing down. I tried to remove the song. Anyway, long story short, this gentleman off to the left here, that brother Ernest is talking to, is a gentleman who walked by who claims to have a PhD in physics from MIT. And so everybody, of course, was all over this guy. And, they're really bombarding him. I was like, oh, go easy on him. And I brought up this point I was just talking about with the ISS in the thermosphere. And he was not, wasn't at the tip of his memory, the temperature of the thermosphere. So I mentioned it to him, and he said, is this a stationary object or an object in motion? And I was like, that's so much worse. Because I thought about it, like now it's in motion in this environment. And he said to me, do you think the ISS would burn up? And I said, oh, yes, absolutely. And he's like, yeah, I think so, too. Just going by the numbers and the figures that I was giving him.
Right. But chances are
he didn't think about it in the, the lack of dense molecules and all that. But
see, that's the part you left out. Right.
He has a PhD in physics from MIT.
Okay, but he had a PhD in physics, but you were, and I'm teasing Jibby, you ambushed him. Okay, so you've clearly studied this, so you know the temperature of the individual molecules, you know the speed, and you also know that it is nearly a perfect vacuum, and you only gave him 2 of those 3 pieces of information.
I did assume that's an ambush. That that's PhD in physics.
That's an ambush.
Considered that within maybe the course of 30 seconds, 10 seconds. You'd think about, okay, it's up there, the thermosphere, okay, object in motion. Like he was asking, specifics, and but you get my point. It was a quick answer. It's not like he spent minutes and minutes.
Jibby, you get my point. You had 3 pieces of information, and you gave him 2. Which, the speed and the temperature, that sounds really extreme. Both of those put together sounds really extreme. The ISS is going to burn up, tomorrow. But if you add in the fact that it's a near perfect vacuum, all of a sudden the speed is not like, it's not really a factor. And then the temperature of individual molecules is not really a factor. Was that a guy going by on a unicycle?
Oh, this guy, you know how these beaches always have their people that come by to entertain
Is he a
Long
busker?
Beach, California. Yeah, this is his shtick.
I just learned the term busking from a magician, Stephen Bridges. Do you know about the word busking?
No.
Yeah. So that means, if you're a street performer, like obviously this guy doesn't have a crowd. He's trying to, you guys are having a conversation with your backs to this guy. And he's like, hey,
You know
over
what he's saying?
here.
He's like,
Hey,
take in
over
the
here.
sun. The sun came out for us today. Take it into
Hey,
your hearts. Take
over
the sun
here.
into your hearts. That's what he's saying.
So,
He was,
so I follow this guy named Stephen Bridges, who's an amazing close-up magician. Amazing close-up magician. I mean, he can do things with cards where like they use the term demon magician, where it's like the only way you could do that is if you have demonic powers. I mean, he's amazing, and he's just a really nice personality. But occasionally he goes out on the street and he, with a hat, and he tries to get up a crowd. I guess he's in London, and they call that busking. Apparently that's a European term. I just had never heard of it, but it's like,
Pancho
a
Pete's probably good at
musician
that.
or a
Yeah.
performer, street performer. So
Pancho Pete learned how to make balloons from YouTube, and
really,
he makes 200 quid an hour doing
wow.
parties and things like that. Well, you know how he's got that bubbly personality, so he
Yeah.
makes balloons, and he's kind of like a comedian and
Yes.
kind of clown performer. He's got it
Did
all.
I ever
That's all he needed.
tell you that? I mean, and Pancho Pete's personality. I actually got him to be contemplative once. He actually was silent and stroking his chin for a moment. Can you believe that? I mean, have you ever heard a crazier story?
You must have caught him early on in this.
So, are you interested in what I said to
Yes,
him
yes,
that
do
caused him
tell.
to be contemplative?
Do tell.
I was talking about the straight line path of the sun on the equinox. And like, we were just having this discussion back and forth about the equinox. And there's all sorts of things you can do. And then when I said that the sun goes in a straight path and that you can actually verify it, you can look up, you can do a sundial, blah, blah, blah. And then he was thinking, well, the only way that would be like a pendulum swing, like the sun crosses across the sky like a pendulum swinging. And then I was like, well, the pendulum has to swing back, right? And he's like, And just for about 5 seconds there, I actually got him to think about it. And then he was off into his usual shtick.
So the both equinoxes are equator.
When the sun crosses the equator. Yeah. So, I mean, we call the date the equinox, but actually the equinox is a moment in time because the sun might be, a hundredth of a degree below the equinox or below the equator, and then it's on the equator, and then it's above the equator. So it actually does cross the equator at a moment in time, but it's close enough to call it the date, that we call that day the equinox. But yeah.
Well, visually, I have paid attention to this, and visually, my sun does not move in a straight line on the equinox. It
But
does
you
look
have
like a slight C.
You have not made a shadow stick sundial to actually verify this because you're going by your feels.
No, I'm going by looking at the sun. Where does it rise? Where is it at noon? Where is it at 3 p.m.? Where is it at
Right.
6 p.m.?
But-
This makes
but-
a C.
How can you verify to me, or how can you convince me that it is going in a C pattern if you are just looking up at the sky and saying, "Oh, I see the sun here. I see the sun here. See,
I can
I see
explain
the sun
that
here."
right now. Easy. I set the tripod up for a 24-hour type of thing, or 12-hour, and I basically do not move the tripod. The most I will do is just move the camera upward.
Okay, so you're sort of manually adjusting the camera, but the tripod doesn't move.
Tripod doesn't move at all. The camera
Right.
will stay in one position, and then I could catch where it rises, and then I'll just slightly move it upward, or I
Right.
could just leave it, do a time lapse, and you will see that the sun is not moving in a straight line.
Well, here's the thing. If you were to set up a shadow stick sundial, you would know for certain because the shadows aren't going to lie.
Why is that for certain and not the camera eyes on the sun?
Well, but see, the thing is, if you were doing this with a theodolite, like if your camera was looking through the lens of a theodolite, where when you are sighting in on that sun, you're measuring the azimuth and the angle of elevation, and you're repeating that every time you do the observations, you now have a body of data at 6 o'clock in the morning, the angle of elevation was this, the azimuth was this. At 7 o'clock in the morning, the angle of elevation, et cetera, throughout the whole day. That would be a body of data. That would be measuring. So nothing against your camera, but you're just not measuring with the camera. You're making slightly more than casual observations. I mean, you're giving a level of rigor that you didn't have before. The tripod's not moving. That's great, but you're not actually measuring anything. Okay, that's where you could either use a shadow stick sundial, or you can use a theodolite, or even a theodolite app would be probably accurate enough because it would give you. Well, the only problem I have with the theodolite app is that it wouldn't accurately measure azimuth, because the only way to measure azimuth would be via the compass, and the compass can be kind of squirrely on these cell phones. So, but the thing is, you've got nothing to lose by setting up. Oh, I'm sorry.
The app would probably be squarely too. I mean, nothing is going to replace the actual physical instrument versus the instrument on your app.
Well, it's garbage in, garbage out. There's nothing wrong with the app, but if the app is taking like data from the accelerometers for tilt and what do they call that? The three modes of an aircraft. It's pitch.
Well, if it's taking it in,
yaw.
then it's designed to see that. It's presupposition that you're on a globe, and then now it's treating it like it's a globe instead of just a neutral observation.
Nathan, calm down.
Charles, I'm so upset, Charles.
You forgot to call me retarded 27 times, and that I'm the least intelligent man that you've ever come across.
Socrates quote. What the Socrates quote. When your opponent has lost, they turn to slander.
So, yes. So the point I was trying to make about the theodolite app is it's getting data from various input sources, and there is no way of telling. Like, for example, if you have pitch, so it's like you take your app or your phone and you tilt it up or you tilt it down. That's really easy because you have an accelerometer. You also can take the phone and you can kind of turn it like you turn a steering wheel, which you wouldn't do if you're taking these sun photos. But I guess that's what roll, and that's also via the accelerometer. But if you shift your body, like if you pivot on your heels, there's no accelerometer that's going to sense a change in direction, right? I mean, like from one photo to the next, like you can't just like turn the phone on. Okay, I'm aiming in this direction. The accelerometer is only pointing down.
So a time lapse of the sunrise to noon, and then kind of 180 the camera, leaving the tripod in its location. So now you're just getting the 180 perspective of the noon sun now, and you just track it along on. And if this does not go in a straight line, that's not
well.
Good
Okay,
enough.
Let me finish my point, and then I'm going to talk exactly to that. So how do you track the pivoting on your heels business, the azimuth? It's done through the compass, and that compass is like my phone. It says, oh, this compass needs to be calibrated, and it says, take my phone and I swirl it around in the air. I have to kind of wiggle my phone around to kind of calibrate the compass. So I know for a fact that the compass feature, at least on my phone, and my phone's a couple years old, is a little squirrely and has to be calibrated regularly. So that was my point, is like you've got these modes of input into the theodolite app, and so the azimuth will be the least reliable. Now, to your point, if you are taking a time lapse of the first half of the morning, from the morning till the noon, and then you turn the camera 180, and then you get noon till sunset, your chances are, if you're capturing the sun in each of those time lapses, you're using a wide angle lens. And if you're using a wide angle lens, it's going to introduce a curve. It's going to introduce distortion. So, I mean, you could prove that to yourself by literally taking a picture of a sheet of graphic.
On the position, on the ground. I have a terrible, terrible position here for sky observation. This is why I haven't done it, because I only have a little patch of sky.
Right.
I'm surrounded by trees.
The sun's filtering through the trees or something?
I would not be able to do it here. I'd have to go to a mountaintop location, or I'm going to put my house on the market this year, and I'm going to locate elsewhere. I am going to consider sky observation in my next location.
Okay.
And I will have I probably won't even have to turn the camera around, because I could probably track it from sunrise to maybe 3 p.m. all without me moving the camera whatsoever. I'd be able to draw the line on the video.
But here's
time lapse of the sun. It doesn't move in a straight line.
Okay, but everybody who has ever measured the shadows, which again, the shadows are objective. If you have a flat surface and you have just a simple anything that's casting a shadow, it has to end in a point, but that thing that's casting a shadow, the shadow will move in a straight line on the date of the equinox. And this has been like done countless times. There's videos of it. You could do it yourself. The thing is, you're not doing it. Like you're telling me that the sun is not moving in a straight line, but then you've got this dodgy setup where you can't really see the sun, and you've got a wide angle lens. And do you see what I'm saying?
No, I mean, I haven't done it on camera. I have observed it, and I've taken note of where the sun's location is, and I know all I have to do is put the camera down. It's going to film what I saw. So it's just a matter of when I can do it.
Jibby, take it to the next level. Like that is literally the whole point of my channel.
Well, the shadows to me is not the next level. Like observing the sun is level 1. That's okay. Step 1. You observe the sun, not like you're looking down. It's kind of like, hey, look at the aliens in the sky. Oh yeah, I see them on my phone. I'm looking down. No, look up.
If you observe the sun, yes, that is step 1. But there is no measurement involved. That's the whole point. There's no measurement involved when you just
not at
look
that point. You're just tracking that it's not in a straight line. Observe.
No, but you can't. But the thing is, you can't discern what's a straight. Like if you go out there and you say, "Hey, there's the sun in the sky," and then you go out there an hour later and you're like, "Look, there's the sun in the sky." You're not going to say like, "Oh, this thing is going in a straight line." Like the human perception is not that sensitive.
This could be based, this could be a thing that might work on both because of my location at the 72nd parallel or whatever up here in the north. Even if it is moving across the equator Earth, because of my location, might make the sun appear to do a C shape, though it may be moving in a straight line from an equator perspective. This just might be one of those that works both on the flat and the round.
But here's the thing: you haven't made the measurement. You've made the observation. I will give you that. You've made the observation, but you have not made the measurement. That's the point.
The shadows thing is, to me, the data from the shadows thing is not going to overpower the visual perspective of the sun that I see. But then again, because I'm in New Hampshire here, and if it is going across the equator line, according to the spin of the earth and all this crap, it might appear like a C to me.
No, it's not, because it's not. The sun is not actually crossing
everywhere on the globe. It's going to move in a straight line. That doesn't even make sense on the globe.
Absolutely, everybody. But
the globe is tilted at an angle and turning. How will it appear to move at a straight line for everybody? On
the date of the equinox, the tilt of the Earth is effectively 0. It's not 0, but on the date of the equinox, it's effectively 0 because the tilt of the Earth is sort of, I don't know how to describe it. Like the sun, like the tilt of the Earth is sideways to where the sun is. I guess that's the best way of describing it. Like if you were the sun observing the Earth, you could swivel around. You could look at the Earth north side up, south side up. You could look at it with a 23-degree tilt. But on the date of the equinox, when you're looking at the Earth, you're just seeing the Earth as half lit, pole to pole, right? Now, if you were to observe the Earth moving, you would say, oh, the way it's moving and it's got a 23-degree tilt. But if you're the sun and you're illuminating the Earth pole to pole, it's effectively like there's no tilt on that date.
So on that day of the equinox is here. Now, if the Earth is spinning,
See, the thing that's confusing for a lot of flat Earth folks is they imagine the sun being close. So they imagine the sun being over the equinox, which means that if you're in the northern hemisphere, like you're up there in Massachusetts, Massachusetts or New Hampshire.
New Hampshire.
You're in New Hampshire.
Just a
that you'd be looking southward towards the sun. Like that's the impression that people get, and that's the impression that I got when I first started studying this. It's like if the sun is above the equator, shouldn't somebody in the United States be looking southward towards the sun? And the answer is no, because the sun's 93 million miles away and much bigger than the Earth. So we're going to be looking, out at the sun. But I hope you get my point, Jibby, is that, your casual observations and your better than casual observations are great, but the shadow stick sundial will give you a series of marked angles, like especially if you measure the height of the gnomon and you mark that, you can actually literally take readings off of your sundial base. You say like the sun was at this degrees in the sky. How many degrees was it in the sky? And you can just trace the whole thing. It's a whole set of data that you can collect.
Well, all right. We just passed the solstice. So what would be the tilt of the Earth right now?
Well, if we just passed the solstice, the effective tilt of the Earth, like the sun is pretty close to being above the Tropic of Cancer. So it's going to be a little bit south of the Tropic of Cancer.
Okay,
so tilted, like approximately like that.
Give me the tilt that you agree with.
Like about, I would say, back off a little bit.
Well, right.
We'll call it like that. For government's sake.
All right, and the sun being far away,
right,
is just heating it directly. Now,
yeah.
How does the heat line stay like this when we have a tilt like this? Shouldn't that heat line right here? Shouldn't this heat line be here? Why is it always at the equator? No matter the tilt.
The temperatures of the Earth are extraordinarily complex. If you, and I don't really know the website you're on. Is that a real time website? Like, is that showing
Earth.nullschool.net?
Okay, but is that showing a temperature map of this date or yes, to the best today, of the knowledge, this date?
Everything is right now.
So why don't we swivel it? Can you swivel it back so that the equator is parallel? Meaning it's horizontal. And then so what you do, so just pause right there. Don't move. Okay. Notice the large majority of that reddish orange band on I'd say the left 2/3 of the Earth, and you see that is higher than being centered. Now on the right 1/3, do you see what I mean?
Yeah.
That you just moved the Earth. So
you're nitpicking
anymore.
Right here though, it's in my favor. So you know what? Oh, right here it's in my favor, and over here it's in my favor, and now it's in your favor.
Right.
You know what I'm saying? But the point is, it's tilted like this.
Yeah. But what I'm saying is, you can visualize
moves,
it.
But
you
it
can
never moves.
Oh my goodness.
Forgot to take in the tilt of the Earth with their heat band.
You could visualize it when you.
I can visualize anything.
When you make the equator horizontal,
you visualize it.
So here's a question for you, Jibby. This is a piece of data. So does this website have historical data? Like, in other words, could we plug in a different date and get a different temperature map? Like, could you plug in December 22nd, and give us...
Look like I can. It has several projections too. It's good.
I like the globe view is easier because you can you could change the tilt and you can see where the equator's horizontal.
This is temperature. This is wind, temperature. It's got all of that fun stuff, but it doesn't have date control.
So the point that I'm trying to make is that you could like make a movie, very slowly roll your cursor over it, very slowly rotate the globe so that you can see all parts of it, trying to keep the equator horizontal. And you do that on June 22nd or whatever. I mean, now is pretty close, but then you come back in 6 months and you do the same thing. You just roll,
I've been paying attention
for
3 years. The heat line is always at the equator.
But Jibby, what I'm talking about is collecting data. In this case, we're literally connecting a screenshot from a website, so it's like, put a little asterisk beside it. But if it's just you and me talking about over this one image, you and I could argue back and forth. We're not going to get any resolution. What we need to see what it is during the December solstice, and if the heat line is further south during the December solstice, well, that would definitely show something. And if the heat line doesn't change in the December solstice, well, then you've got the point.
And I'm also picking a particular week where we're about to have 1 week of the 90s plus, which I've never heard of in New Hampshire. This is the very first time this has ever happened here. So we have an extreme band of red up here. This is the abnormal high that is a brand new. It's going to be a record this week for New Hampshire. But so this is a very bad time for me to point this out. Point is, this band stays here year round. I've been paying attention to it. And this is something us flat earthers, we all talk about, the band doesn't take into account the tilt.
It's your feels. If you could produce a series of images that was taken.
Cold?
in
with the
December,
tilts right here.
if
There you go.
if you can produce a series of images, the thing that a lot of people don't understand is like, whether like with all of the cutting edge technology we have, we can really barely predict the weather 5 days away. you know I mean, beyond broad temperature things. I mean, you can't tell that it's going to rain 6 days from now. Like that's just not possible. The weather is so it's driven by chaos. There's broad patterns, and then you could study those patterns. But the point I'm trying to make to you, Jibby, is that if you wanted to make this a study, you could make it a study. Not just clicking on this website and just saying, oh, look at the temperature bands, and then clicking on it 6 months later and like, oh, I don't notice the temperature bands changing. That's going by human perception.
Well, let's do Google. Oh, let's do anything. Earth map temperature. And we'll see what it comes up with. Earth global map. Earth, well, that's the same one. I was just saying.
Okay.
It's just the first link. Land surface Earth observatory. They're all going to show you the same thing. Let me get to the temperature setting or wherever that is.
So because we're going to close out in about 13 minutes. And yesterday's hangout was really...
Come on, you went an hour and 50 minutes.
I know I went an hour and 50 minutes, but the thing is, my wife is going to... I'm putting a serious strain on our relationship, spending so much time. So we do have a comment in the chat from Flat Earth New Zealand, and I have not been reading the chat. I'm sorry. I really haven't been paying attention, but he says...
Here we are on this solstice, and where's that heat band?
Well, it's in the tropics, right?
Not taking into account the tilt for the heat band, the sun direct heat. This heat
so does this look? There is a date function. So what you can do is you can actually take a screenshot of that.
Oh, good. Give me a date,
and then you can change the date.
Give me any date. Right? Here we go.
December 22nd.
All right, let's pick it.
So I was going to say that Flat Earth New Zealand, or Flat Earth NZ.
Look at that! Isn't that crazy? Look at that! December 22nd. It hasn't really changed.
But you gotta take a screenshot. You gotta compare the screenshots.
Let's do June. Let's do June of 2017. Ready? And did it even change? Well, let's pick the date.
You haven't clicked on it yet.
There we go. Wow,
it went north. I definitely saw it go north.
Oh, come on.
I saw it go north. Here's the thing. You could take a screenshot, right? You could take a screenshot and go apples to apples. That's the thing about, I mean, that's the whole point, Jibby, is, all right, so let's talk brass tacks.
Oh, look at that. Isn't that crazy? Look at that. Look how it shifted.
It did shift.
June 2016.
It definitely shifted. But
Jibby, ready? Close your eyes. Don't close your eyes. Ready? And presto, look at that. Hey.
Jibby, I can tell the date just by picking the temperature map.
It should have been boom, 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 boom.
So Jibby, the point that I'm trying to make, and I know you're going off the rails here with silliness, but Jibby, just take a moment. The point that I'm trying to make is there are casual observations and there are careful observations. So for example, using this Ventusky website, you could like take a little screenshot of like, just say North and South America, or even just the Pacific, like just a screenshot of the Pacific, and then change the date, and then take a screenshot of the Pacific again. And then like, obviously just not 2 dates, because we do have cold weather and we have warm weather, and that the seasons do change. But my point is that you could then make a comparison. You can make an apples to apples comparison, which is not based on feelings and perceptions. That's the point, is collecting careful observations, careful data.
Their data. Right? I can't even tell the difference. I just did June to December. All right, that might have moved up a little bit. Let's try it again. Back to June and 22nd. No, not really. Just the lighter colors changed, but this purple band stayed equatorial. These colors, they shifted in the greens and the yellows a little bit. Yes, this stayed equatorial despite the tilt, and it even tells you can just see there it gives exact temperature as I just cruise over this. Now, yes, I can be meticulous, go through every month and do temperature readings, but as we can see, it's going to stay equatorial. I'll go October 21st, equatorial. It stays this way.
So anyway, we've got 10 minutes left. I don't want to beat a dead horse to death. I did want to address one of the comments. Flat Earth NZ had said, and this was a while back, but he was talking about how we can't duplicate this with a vacuum. And the thing is, there are certain things that you can duplicate in a lab, and there are other things that can't. Like, for example, you could build a paper mache model of a human cell or an animal cell and say, oh, here's the nucleus, and here's the ribosomes, and here's the Golgi apparatus, and here's the mitochondria. But you can't build a model and then have it actually function like an animal cell. So it's like you could sort of build a physical model and sort of understand the sizes, the locations, the relationships, but you're not going to build a model that is actually a working model. When I was a kid, I built a model of a V8 engine, and it was called the Visible V8, and it was made out of clear plastic parts, and it had little light bulbs for the spark plugs, and it actually had a distributor where it literally sent electricity through the 8 cylinders, and the cylinders went up and down. It had a crankshaft, but I mean, it had to run on electricity. It had to run, like it was a model of a V8 engine, but it wasn't a working V8 engine, So the things that we're talking about here with the planet is like, yes, the planet Earth is surrounded by the vacuum of space, but you can't duplicate that in the lab. You can't say, well, let's make this little pretend planet, because this little pretend planet is not going to have gravitational pull that's going to be, 1/1000th of the pull
iron
of
core
the Earth.
spinning center, and there's no way to make a working model of the Earth in a lab.
Right.
I understand that.
So you can make diagrams, and you could make, physical models that are sort of representational of the orientations and the space and the layers, but you can't you can't get a working model, but models are helpful for, visualizing things and for understanding things. But they're not duplicates of the thing. Like you can't duplicate the thing, with the model.
All right. Final question before we close it out.
Sure.
Okay. What is the stronger force, vacuum or gravity?
Vacuum is not a force.
There's no force of a vacuum?
There's no force of a vacuum.
I mean, a vacuum doesn't. Did you see that video of the train car imploding?
Yes. And that train car was located in a pressurized environment, namely the Earth's surface.
So the force of a vacuum can't lift cars and things like that. The suction, the force of a vacuum is not a powerful thing. It doesn't force the air out of something contained with pressure.
So I think what you're misunderstanding is an artificial vacuum in a pressure environment can be very powerful, right? So if you take a look at that train car, and then, that train car was a spectacular example, but it's like that train car has a surface area, which you can measure in cubic feet, or you can measure it in tens of thousands of cubic inches. And so the Earth's atmosphere is at approximately 15 pounds per square inch. But did I say cubic inches a moment ago? I meant to say square inches. So you measure the surface area of this train car, and like I said, it's tens of thousands, maybe even millions of square inches over the surface of this train car. Multiply that by 15 pounds, and you get the weight or the pressure in pounds, which is a force on the outside of this train car, because the inside has been evacuated of air. And then, of course, the thing is going to crush. At some point, it's going to crush. All right. So that is of an artificial vacuum that is being produced in a pressurized environment, which is, sea level, the Earth's surface. So, but out in the outer space, there's no force. The vacuum doesn't have a force out in outer space. It's
wait. So there's no vacuum force.
There's absolutely no vacuum force, unless you are introducing an artificial vacuum here on Earth or in any other pressure environment. The key, Jibby, is the pressure differential. And this is where I get Quantum Erasure to go off the rails, because he thinks pressure differential is done with a division sign. But a pressure differential, the analogy I have is like, if you can imagine a piece of plywood, 4x8 sheet of plywood, and you get 5 guys on one side of the plywood with their hands up against the wood, and you get 3 guys on the other side of the plywood, and they're pushing against the wood. And it's like, it's not a tug of war, but it's a push, it's a pushing contest. You follow me? The plywood is being pushed on one side by 5 guys, pushed on the other side by 2 guys or by 3 guys. And the 5 guys, I mean, if everybody has the same strength, if everybody's wearing the same shoes, chances are the wood is going to push towards the 3 guys, right? Well, what happens if you remove two of the people? One guy from the five guys side, one guy from the the three guys side. Well, now it's two versus four. It's still going to move towards the two guys with the strength of two men. Does that make sense? It's like you've got the pressure differential or the force differential is two men. You have two men greater on one side of the board than the other. And so what if you have a pressure environment? So you've got like a high pressure over here and a low pressure over here. It's going to move, right? Well, now you evacuate something entirely, and so the pressure is only on one side. Yeah, you're going to get a tremendous amount of force, but that's in a vacuum, an artificial vacuum in a pressure environment.
Do you agree that the atmosphere of the Earth expands and contracts?
Oh, I'm sure it does, but it relates to temperature. It relates to the various things that produce gas. I mean, I'm sure that the volume of gas of the Earth's atmosphere is not 100% constant. There's various forces at play, and I think I read somewhere that it was like even like solar radiation. There's various types of radiation that can cause the atmosphere to expand and contract, and so yeah, that's
what kind of impact would this have on this ISS?
My understanding is that when the atmosphere expands, then it produces a slightly larger drag on the ISS. Now, when we talk about drag on the ISS, we're talking about, something that is probably could be expressed in millionths of a pound. That the ISS is not plowing through air; it is occasionally hitting a molecule of gas, right, which will slow it down over time, and it does.
Got to be hitting more than an occasional molecule. It's only halfway in the thermosphere, and there's still, I want to say, at least a couple of 100 miles of technically atmosphere, where there's measurable, noticeable.
Yeah, there's gas particles. It's not a pure vacuum
that are not in a vacuum space that are part of this atmosphere.
But the point is, the ISS does slow down, and it needs to be boosted. The slowing down of the ISS causes the orbit to retard.
The molecules that are creating the friction to slow down are molecules at 2,000 degrees. Now add in the speed.
Didn't we already have this conversation?
But you're assuming very thin, like you're assuming one scenario where the molecules are so sporadic and they're not really having an impact, but it's an assumption.
Well, no, but it's empirically testable, and it has been tested in the lab, and actually in space, where like they spend up space vehicles and they actually measure the stuff.
Allegedly.
So, well, I mean, you could just reject that evidence,
from a separate source.
You could reject the evidence, but even the temperature sensors on board, when a flat earther sends up a high altitude balloon and it has a temperature sensor on it, you could get the readings from that.
And I have, and they go from extreme cold to like minus 70, minus 80, but then they level off around 100,000 feet, right back to zero. So it's like
it depends on the orientation of it, and oftentimes the people who set up these payloads, they stick it in a like a little styrofoam cooler, sometimes with a little heating pack, So this stuff is empirically measurable. Anyway, it is
almost, maybe it's too thin to measure when it gets to that certain height. Right?
So, but the point I'm trying to make, Jibby, is that like there's no data on, like, you're asking very good questions, but this stuff is measurable.
I'm trying.
And when I say that it's been mesurable, you're like, well, I'm just going to reject. I'm just going to reject. I don't trust the person who did the measurement.
From the source that we've all pretty much, their credibility is shot with us.
Well, yeah, but forget them. Forget that shadowy organization.
Get a second, third, fourth, fifth source to confirm. That's not all government teams.
Then find those sources and confirm it. But the thing is, the concepts that you're talking about like whether the exosphere or whether the thermosphere is actually hot, this is not really a topic that is for debate. I mean, yes, we can debate it, but like, I'm not going to convince you with me just speaking words over the internet. The stuff has been tested. It's been tested thousands and thousands of times. And amateurs can send balloons up, like the balloons actually, I don't know, do they go into the thermosphere, or I don't know where the thermosphere starts, but anyway, it is now 11 o'clock Eastern time. You want to give some final words? But the thing is,
Gotta
we're going to
hit
do
more
this.
than an
We're
hour.
going
We're
to do
just
this
getting
regularly.
warmed up.
We're going to do this regularly, Jibby. So,
Yeah.
you know,
Yes,
like,
we are.
so,
If you, yes.
yeah. So, do you want final thoughts?
Send your prayers and thoughts to our friends Chris Rock and Josh Walker, Uber Flat Earth. They need all the support we can give them right now, and that's right now is my own priority and concern, really, with all this. Just the well-being of my friends.
Okay, I agree with you 100%. Everybody in the audience, and when you watch this video later, please send your prayers to Chris Rock and Josh Walker. Josh Walker.
Yes.
And they'll be doing what is a fundraiser for Chris.
For Chris Rock.
It's going to be
weekend. Yep.
next weekend.
24 hours.
So I want to thank everybody who's been in the chat. The chat's been very civil. I've only been able to glance over and see occasional messages. I'm sorry I have not been reading the chat. I've been too busy sparring with my good friend Jibby.
Apologies.
Yeah. But thank you so much for all your kind comments and your questions and your civil your civil discourse in the chat as well. Jibby, I thank you very, very much. I'm going to end the broadcast now. Thank you so much, everybody. Have a good night.
Thank you, everybody.